Okay, continuing on with section 6.2, solving systems of equation by substitution. Let's look at another example. Negative 3x plus y equals negative 14, and 2x minus 7y equals 22. The first step in the process is to solve one of the equations for one of the variables, and you get to pick either variable in either equation. But I don't want to solve for x in either one of these, because to solve for x here, I would have to divide by negative 3 eventually, and that would create fractions. To solve for x down here, I'd have to divide by 2 eventually, and that would create fractions. If I solve for this y, I eventually would have to divide by that negative 7, and that would create fractions. So the best pick seems to be to solve the first equation for y, because it has a coefficient of 1, and you could solve that one without ever having to divide, and that means you won't be introducing fractions. So what I'd want to do is move that negative 3x to the other side of the equation, and we would do that by adding 3x to both sides. That would cancel it on the left, and when it shows up on the right hand side it would be a positive 3x, and then we'd still have that minus 14. And once you've solved one of the equations for one of the variables, then you want to substitute that into the other equation for that variable. So I'm going to write 2x minus 7y equals 22, but when I get to the y part right here, I'm going to substitute this 3x minus 14. So I would have 2x minus 7 times y, but instead of the y I would write 3x minus 14, and that would be equal to 22. And the good news about doing that step is now if you look at this equation, it only has one variable in it. So we could start doing the algebra to solve for that variable. That would start off with removing these parentheses using the distributive property. So 2x minus 7 times 3 would be minus 21x. And remember, we're distributing the negative 7, not just a 7, so negative 7 times negative 14 would be positive, and 7 times 14, I believe, is 98. And then we have that equal to 22. These two terms are on the same side, so I'll just combine them. This constant term I'd want to move to the other side, so I'll subtract 98 from both sides. And let's see where that takes us. 2x minus 21x would be negative 19x. And then on the other side, 22 minus 98 is a little bit messy. So let's see, 98 minus 22 would be 76. But the bigger number is the negative one, so this would be equals negative 76. And then I want to get that x by itself, so I divide both sides by negative 19. The 19's cancel over here. Unfortunately, 19 does go into 36 evenly. It goes in 4 times, so when I solve that, I get x equals 4. And that's not the solution of the system. In a sense, we're only halfway done because that's just our x value, but actually we've done way more than half the work. All we have to do now is take this x equals 4 and plug it into any of these 3 equations to solve for y. And this one has y by itself already, so that would be the best choice. So I'm going to take this equation and this solution, and I'm going to put them together to get the value for y. So y would be equal to 3 times 4 minus 14, so that would be 12 minus 14, so y is equal to negative 2. So here's the first part of the solution, there's the other part, but there's not 2 solutions, they're just one, and so we always write our solution as an ordered pair. So the x is 4, comma, the y is negative 2, and that's the part I'd box as my solution. Alright, let's move on to the next example and see a couple special cases. So we're going to use substitution to solve this system also. And our first step of solving one of the equations for one of the variables is actually done already, because the first equation says y equals 2x minus 15. So I'm just going to take that one and substitute into the second one. So when I get to this y right here, I'm going to substitute for that 2x minus 5. So we have the negative 4x plus 2y, but the y is 2x minus 5, and then that's equal to negative 6. And so right away we've got that situation where we have just one equation, one variable. So we want to start doing the algebra steps, so we would distribute that 2, and that gives negative 4x, we'd copy, and 2 times 2x would be 4x, and then 2 times negative 5 would be negative 10, equals negative 6. And if I just followed the same pattern as before, I would want to combine these two, and at the same time move this 10 over to the other side. But when I go to combine these two, something kind of surprising happens. These two cancel each other out. So I just get a 0 there. These cancel each other out, so I get a 0 there. So the left side is just 0. And on the other side, I have negative 6 plus 10, which is 4. And if you go to solve an equation and both sides drop out and you're left with the two numbers and they're not equal to each other, that is called a contradiction. And when you get a contradiction, that implies that there is no solution. So they told me to solve, so this would be the answer. I would just need to let them know there's no actual solution to that. So let's go ahead and take a look at why that happens. What we want to remember here is that when you're solving a system of equations, you're trying to find the point of intersection of those two lines. And so if you think about what we saw in the graphing section in section 6.1, if you get no solution, that's supposed to happen because the lines don't intersect anywhere. And with just a little bit of algebra, we can see that's true. This problem is done, so I'm just going to move in here in the purple to do the extra work. So let me point out something on our first equation. For our first line, the slope of that one is 2. And I can see that just by looking at the coefficient right there. When I go to the second one, if I wanted to see the slope, I'd need to do a little bit of algebra. So let me squeeze this in. You don't need to necessarily write this down, but I do want you to see the work. So if I move that negative 4x over to the other side, it would be by adding 4x to both sides, so it would become positive. And then I'd want to solve for y, so I would divide everything by 2. These 2's would cancel, and reducing the rest, I would get y equals 2x minus 3. And so notice our slope right there on the second line is also 2. So if two lines have the same slope, they're either the exact same line or they're parallel lines. And we notice the y-intercept of this one is negative 3, and on the other one it's negative 5. So they have the same slope but not the same y-intercept, so that means they would be parallel and not intersect. And let me just show you that on the graphing calculator real quick. I can enter the first equation in by going to the y equals menu. I have a line there already, so I'll clear that, and I have a plot that's turned on, so I'll select that and turn that off. And enter in my two lines. So the first line, y equals 2x minus 5, and then the other line, y equals 2x minus 3. And I'll just go to a zoom standard here to get the negative 10 to 10, negative 10 to 10 window. And there's our first line, and here comes our second line. As you can see, those look parallel. The fact that they have the same slope proves they're parallel, and if you're looking for a point of intersection, there's not going to be one anywhere for parallel lines. So if you're working on a system of equations and you try and solve for the variables, and in that process your variables drop out, look to see what's happening with what's left over, and if they're not equal like this, that's a contradiction. It means you have parallel lines, and it means there's no solution. I think we should probably squeeze that thought in here. So in addition to saying contradiction and no solution, we could give the reason, which is that there are parallel lines. So the logic is kind of like this. We reach a contradiction. That tells us we have parallel lines, and that tells us that the answer is no solution. Let's go ahead and look at the final one. Use substitution to solve this system. Again, we have x already by itself, so I'm going to take advantage of that, and I'm going to substitute in place of this x right here, 2y minus 1 from the other equation. So that starts off this 4 times x, which I'll substitute the 2y minus 1 into that spot, and then minus 8y, and that's equal to negative 4. And then we do those same steps. We have parentheses, so I'll go ahead and clear those using the distributive property. So I get 8y minus 4 minus 8y equals negative 4. And when I go to combine these two, what I should notice right away is that they cancel out just like last time, and I'm left with negative 4 equals negative 4. So again, my variables have dropped out, but this time what's left over are two numbers that are equal to each other. When there's no variables and the two sides are equal, we say that's an identity. So then the question is, what does that mean? So let's take a look at these two equations like we did on the last one. And this work is actually optional, but I just want you to see what's going on. So on this first one, we have, let me rewrite that as 2y minus 1 equals x, so I just swapped the two sides. Add 1 to both sides would give me 2y equals x plus 1. dividing everything by 2, I would get y equals 1/2 x plus 1/2. That's just dividing all three of these terms by 2. Let me show that step. So those cancel, and then we get the 1/2 right here and another 1/2 there. Now let's see what happens with the second line. Take this negative 8y, move the 4x to the other side, so that would make it negative 4x. And then I have the minus 4. Divide all three of the terms by negative 8. And then reduce. Here the negative 8's cancel. And I just get y equals, negative over negative would be positive, 4 goes into 8 twice, so that would be 1/2 x, and here the negatives cancel each other, and 4 over 8 is also 1/2. Notice that those are the same line. So if I can go ahead and squeeze in the answers here, whenever you get an identity, what that's going to tell you, and you don't have to do this work to show it, if you get an identity, that means that you had the same line. And that's not the answer, though. Somebody told you to solve. So what we would put for our answer, let me squeeze that in down here at the bottom, is that there are infinitely many solutions. So when you're trying to solve a system and your variables drop out, that always means that you had the same line. And, well, if the variables drop out and what's left is equal, that means you have an identity. That always means you have the same line, which means your answer is that there are infinitely many solutions. All right, that wraps up section 6.2.